Hello everyone, my name is Chinmaya and I welcome you to part 3, which is the final part of the free OSM GIS vector layers tutorial series. You will recall that in part 2, I demonstrated how to extract many commonly used GIS layers by creating queries using the Quick OSM plugin inside QGIS. Each of these queries require one or more key value pairs. Given the hundreds of key value pairs used in the OSM database, it becomes difficult to remember and recall the right key value pair to create queries for extracting features of interest. In this video, I will share some tips and resources to find out best key value pairs to extract any layer through a quick OSM query inside QGIS. I will also share an online resource that can do the same without using QGIS. Let's start with a quick recall from the previous video of the issue that we will be addressing in this tutorial. I've been using keys and value pairs, and I've just tried to show you some of the important ones that are used for drawing out vectors from OSM database. But the OSM database is a gold mine of information, and you can pull out many more vector layers out of OSM. So how do you get to know what keys and values you should actually be using? Now, one of the problems and advantages both of OSM is that it permits contributors to use their own or invent their own key and values or tags and attach them with features that they are digitizing. They provide guidelines and they expect people to use the keys that are already existing, but they don't prohibit people to create their own keys and values. So what has happened is that this has created a large number of keys and values, and to find the right key and value to extract a feature can sometimes be problematic. So how do we find out the best key value pair for extracting vector layers from the OSM database? Well, the answer is the Query Features button on the OSM website. Let me demonstrate this foolproof method that I use to find out key value pairs that you require to build queries by eliminating any prior knowledge and guesswork. To demonstrate this technique, I have created some examples in a section of an area of the Gujarat state of India having a diversity of cover types. So the first thing that we want to do is to open a web browser and go to the OpenStreetMap website www.openstreetmap.org, as you can see on the screen. Just type in Kandla Airport, that is Kandla Airport, in the search box and you should reach the area shown on the screen. Zoom out a bit to roughly create a window like you see in this video. There is absolutely no problem if you are not able to bring in the exact area inside your window, as we will be zooming out and zooming in and panning as we proceed. Just to make life a little bit easier, you will see a number here. In my case, it is 13. This number indicates the zoom level. So I'm currently seeing this map at zoom level 13. If you have a different number, you can just simply override this and enter 13 here, and you should have the same zoom level inside your window. So let's say, for example, I want to extract polygon boundaries of all these dark gray areas that I see on the map. So my problem is I really don't know what to type in the key and value boxes in the quick OSM dialog inside QGIS such that I can extract these black or dark gray areas that I see on my screen. So how do I find the correct key value pair? Well, you have to come here and use this button as I have shown before. This button is the Query Features button, but it works only when you zoom in a little bit. If you are not zoomed in enough, it will show you zoom into Query Features. So let us just zoom in one of these polygons and then just come here and click on this button. You will notice that it now reads Query Features. So I'm going to come here and click on this button, and then come and click on any gray part of this polygon. So as you do this, you will find that it's a query, and as we mouse over, you will see that we are able to get the polygon boundary right here. So let's click on this link, and what we see here is land use query. So this is the key value pair that we can use, land use for key, query for value, that we can use inside QGIS here to extract this particular area. As you can see, I have the same area inside QGIS, inside my canvas extent, and all I need to do now is to just simply type in that particular key and value, and I'm just going to do that. So I'm going to pick up land use, and I'm going to use the word query, and I'm interested in an area inside my canvas extent. So as I've explained before, we'll choose canvas extent here, and I'm only interested in polygons. So as we run the query, you will see that we will get an answer, and we will be able to successfully pull out all the dark gray areas inside QGIS. So one layer has been added here, and we have successfully extracted these dark gray areas that we were seeing on our map here inside the browser. Likewise, we can explore any feature using the Query Features button, find out the key value pair, and then go inside QGIS and extract the same using the Quick OSM dialog box. So let's investigate a few others. And as we click on these features, let us keep a note of them. We will go and try to extract them inside QGIS after we have finished here. So say for example, I was now interested to extract all these pink areas, these light pink areas. I don't know what they are. So I'm going to come here and zoom in a little bit, let us say into this area. And then I'm going to go here and click on this light pink area, trying to avoid these buildings because I want to know what exactly is this pink area, what does it represent. So I'm going to come here and click on this, and then just simply mouse over. So you will see that a polygonal boundary has been picked up. It is actually an industrial area, telling me that all the pink areas that I'm seeing in my map are industrial area polygons. So if I click on this, I should be able to get key value pairs. In this particular case, land use industrial should bring out all the industrial areas in this particular view, and I can just simply make a note of it, land use industrial. I can go back to QGIS and then type in land use industrial inside my quick OSM query box, and should be able to get all the industrial areas inside the canvas extent. Let us try to go to the airport and try to see what we can pull out from the airport in terms of vectors using the same technique. My problem is I don't know what is the key value pair that I have to use. So I'm going to come here, click on the query features button right here, and then go and click on the airstrip, one part of the airstrip. And it is showing me whole polygon for the airport. I can just come here and click on this, and I can find out the correct key value pair. There are lots of key value pairs here, but one good key value pair that picks up all the airports in an area is Aeroway Aerodrome. Key is Aeroway and the value is Aerodrome. So we can take a note of this to extract polygons of airport, Aeroway Aerodrome. Let me do away with this. Let us zoom in a little bit more so that we can see the airstrip in more detail, and try this one more time. I'm going to come here and carefully position my mouse on the airstrip, and you will see here that there is a vector for the runway itself. It is runway 523. We can click on this, and we now know how to extract runway vectors. The key value pair to use is Aeroway Runway. As we zoom out a little bit, we see something here. I want to know what this is, what kind of key value pair I need to use to extract all these areas which are having small blue dashes. Let me do away with this. I'm going to use the exact same technique. So we'll zoom into the area and then click on the query features button and come on to the edge of this blue dash polygon, trying to avoid any other feature that might be confusing, like a road, for example, on this edge. But we have chosen this edge because it's completely free. And coming on to the edge, we'll click this and you will see that we have identified a wetland feature. Let's click on it. So this entire blue dash polygon has now been identified. And we have come to know that this is a natural wetland. So we can identify such kind of polygons using key natural and the value wetland. Let's zoom out a bit and explore some other features to get this idea. And I'm just going to go to the left and just zoom into this particular area. I can see some very distinctive features right here. So I want to find out what is this yellow area, and I can just simply zoom into this area and click on this, and then just simply use my query features tool and click inside the polygon, and I can see that I have something here, and this is farmland. So when I click on this, I see the correct tag that I can use. Land use is equal to farmland. So I can extract all kinds of farmlands in this area by using this particular key value pair, land use, farmland. All I need to do is to just simply head back again to my QGIS and use land use is equal to farmland after I have brought that particular area in my view. So I have that area in my view now, and I can just simply type in land use is equal to farmland, and I can just go ahead and press run query. And you will see that all the farmland has been picked up in that particular area. Let's try a few more. I'm curious to find out what this is, and so I'm just zooming in, and I can just use the same technique, click here and then click inside the polygon, and you will see that this is the symbol for wetland, and I can just come here and click on it, and it says natural wetland. There are other key value pairs also. For example, we can see that this is a swamp, but then one of the keywords that we can use is natural wetland. Another one that we can use is wetland and swamp in this particular area. So let's do one more for node features. Let's zoom into this area. And as you zoom in, you will see some peculiar icons right here. Let us try to find out a little bit more about these. So I'm going to come here and click on my query features button, and then just come and click on any one of these icons right here. So you will see that we have a node feature here. Let's just click on it. And it is sure enough a wind turbine. So the key and value pairs that we can use to extract wind turbines from an area could possibly be either generator colon method is wind turbine, this is the key, this is the value, or otherwise we can also use generator colon source and the value is wind. So either of these two key value pairs should be enough to bring out all the wind turbines in this particular area. So let's head to QGIS and try this out. So I'm zooming in into this area inside my QGIS. I'm inside QGIS now, and I'm zooming into this area, and let us bring in a few of these in view. And I'm going to click on the quick OSM icon, and I will go ahead and use the key value pair generator source, and wind. I could also have used generator colon method and win underscore turbine. I could have used that as well. In this particular case, I'm not interested in lines, multi-lines, and polygons, only interested in points. And the area in which I am interested is my canvas extent. And I can just go ahead and run the query. I have an answer now, and you will see that all the windmills in this area have now been captured as a point layer inside QGIS. So using this button, the query features button, you can just simply go to any object that interests you, zoom in, and then just click on that particular object to find out the key value pair that can be used to extract the vectors for that particular object. Let me now share some other online resources that can help you further research suitable tags and key value pairs. I have provided links to all these resources in the description box below. The first of these resources is the map features page from the OSM wiki. So let's head to the map features page and explore it. The map features page is a great resource for researching key value pairs. As you scroll down, you will find numerous options, and when you click on an option, you will then see a large number of key value pairs associated with that particular key. They provide a small description here, and they also give a photograph as to what they mean by this particular key value pair. So this is a fantastic resource. You can keep researching on and on and on in different categories, and this is just for one single key. So as you scroll down, you will find numerous options that you can click on, and then you have key value pairs that you can just simply copy and then come inside QGIS quick OSM dialog box and then try them out here, enter the key, enter the value, and you can then try to extract features of interest. So this is a really great resource. It's very exhaustive, and you can just come to the map features page and explore this very exhaustive resource for key value pairs. Another informative resource about OSM tags and key values is Taginfo. You can reach this site using this address, taginfo.openstreetmap.org. I have given this link in the description below. This site shows statistics about which tags are used most and in which geographies. It is a great resource to look for key value pairs if you are looking to find vectors for something specific. It relies on up-to-date usage statistics. I am recording this on 10th April, and you can see that the data that it is using is absolutely current. So when you come to this site, you have a few options. You can investigate popular keys by clicking here, see all the keys, and clicking here will show you the most common tags that people are actually using. So if we click here, you will get a list of all the tags that are most popular. You can see count of objects, and if you notice here, this is just page 1 of 682, so you can move forward and look for more tags. These are all tags that people are using very frequently, and if you're looking for something inside these pages, you can always come here and type in that particular word, and you might get keys that are popular in that particular subject. So for example, if I typed forest, there are pages for forests, and the most common keys are land use is equal to forest and so on and so forth. So you can just investigate some of these pages by coming to the tags section and just try to see some of the common tags that people are using. And of course, you can always come here and look for any tag that you are wanting to get a key value pair for. This side right here are all the keys. So if you click on this, you will see various keys here, and again you can type any topic of your choice and try to look for keys in that particular area. Now if you just look here, you will find that the key building has so many objects in the OSM database, and 0.46% are nodes. A large number of these objects are actually ways which make sense, because most of the time buildings would actually be rooftop polygons. If you look here, it shows you the number of users who last change objects with this particular key. More importantly, when you come on to the extreme right, you will see some of the common values that are being used with building. And these values are building is equal to yes, building is equal to house, building is equal to residential, and so on and so forth. So if you click on any one of these, you will then see the statistics for that particular key value pair, building is equal to residential. And one of the interesting things here is that you can click on this tab that is map, and it shows you the usage of this particular tag, building is equal to residential, in different parts of the world. So you can see here that a large part of the world is using this tag. And if you are located anywhere in the areas which are demarcated as red, you can hope to find a lot of features in the OSM database if you were to use the key value pair building is equal to residential, which would tell you about residential building. So you can look for any key that you are basically interested in. Just click on a key, and then you can come here also and click on values. So it will show you what are the common values that people are using with this particular key. Natural is equal to followed by these values. These are the more popular ones, tree being on top, water, wood, scrub, etc. And if you were to come here and click on this, you will find that very few places in the world are actually using this key natural is equal to landform. So if you are located anywhere in the gray areas, using this key would probably bring nothing out of the OSM database, and you can expect answers only at places which are red. So this is a great resource. If Taginfo is presenting a lot of information for you, you can use a site that makes this a little simpler. It is called as Tag Finder, and I have included a link to this site in the description below. And this actually uses Taginfo, but then it has a cleaner interface. So say, for example, if you were looking for building and then just click here. So you will see various options of building is equal to star, which means all buildings, building colon use is equal to something, building colon architecture is something. You can click on these and explore these further. Building is equal to house has been used by quite a few people. So you can get ideas, and of course you may or may not get an answer depending upon whether this tag has been used in your country for features that have been mapped in this particular category. So these are some online resources that you can explore to find out popular key value pairs for your searches. Now let me show you a way using which you can try out many queries, and you don't need QGIS for this. Whatever you try out, you can also export and then bring it inside QGIS or ArcGIS. So the first thing you want to do is to go to this website. I have provided a link in the description below. The site is overpass-turbo.eu. When you reach this site, this is what you see. On the left-hand side, you see a query box where the query that you will be creating will be displayed. On the right-hand side, you see the map box, and you can see the results of your query right here. There are a few buttons, and one of these buttons is toggle to wide map. So if you wanted to increase the area that you want to cover, you can just come here and click on this toggle wide map, and you can then have a bigger area. Click on this once again, and you get your query box back. On the top, you have a few buttons. I'll explain these to you in a second. So the query that you create here, you can run, and the results will be displayed. Once you are happy, you can click on export, and that particular layer will be downloaded on your computer, and you can use it inside your favorite GIS package. And this particular site is drawing vectors out from the OSM database itself. It's just that you can choose which layers you want exactly in a similar fashion as we have been doing before, but without using QGIS. This is the wizard button that we will be using. You can save a query using this button, and then you can reload that query at a later time. There is a button for settings, and there is a button for help. You will see here that there are two tabs, one is map and one is data. We don't use this data tab very frequently. Let me show you how to use this in the same area that we have used in the previous examples. So let us come here and just type Kandla Airport, and you will see an option here. So just click on it. And I'm using these buttons to zoom in and bring in that exact same area in our view. So you will recall from our previous discussion that these dark gray areas were land use query. So if we wanted to extract those polygons inside Overpass Turbo, we can just come and click on the wizard button. And what we are going to say here is land use is equal to, and we'll have to put this inside quotation marks, QUARRY. Close the quote and then click on build and run the query. So we will come here and click on this, and you will see that the same polygons have been picked out, and the query to bring out these polygons has now appeared here. So this is the query that has extracted all these polygons, and this is the same code that you see inside QGIS. If I can just take you back to QGIS. So when you click on this button, show query, you see some code, and the code that you see in the Overpass Turbo website is the code that is written here to extract features after you have entered all the parameters inside this dialog box. So let's head back. Let me tell you quickly a little bit about this query. As I have already explained before, there is a timeout value. This is for comments. And then you will see that the query part is just basically saying, bring out all the nodes where land use is a query. And this B box is basically defining the area that we are seeing inside the window. This is the canvas extent. So what we are saying here is bring out all the nodes, bring out all the ways, and bring out all the relations where land use is equal to query. And the area that this search has to confine to is the bounding box or B box, which is this area that you are seeing here inside your view. And then the last section just simply goes ahead and prints out the results of this particular query. So this is how Overpass Turbo basically works. One of the great things about this particular format is that you don't need QGIS. Just simply come here, click on the export button, and you will see a few formats in which you can download this data. You can either choose KML or GeoJSON, and just click on this. So you will see that the polygon has now been exported, and all you need to do now is to just simply grab this, go inside QGIS, and just simply drop it here. So as you drop it here, you will see that all these polygons that you extracted using Overpass Turbo are now inside your QGIS environment, and you can then right click and then just go to export and save them as a shapefile. Export has a few other options. Apart from saving your file as a vector layer, what you can also do is to save a PNG image for your presentations if you wanted to. So you can just come here and click on it, and you can then use this image inside your presentations. And if you scroll down, you can also download or copy this query, the code of this query, and use it for further reference. You can also create an interactive map. So you can explore some of these options. So once you get the hang of it, although it appears a little bit nerdy, you can just come here and then just keep writing your queries. You can just come here and say, or land use is equal to industrial, and then just simply go ahead and run this query to extract industrial polygons as well. And if you use this button right here to get a wide view, this query box will disappear, and you will see that you now have a wider view. And because the query is already there, you can run this query and include industrial polygons and quarry polygons in this particular area. So you can widen this view and then you can always click on it and come back. This button here just toggles data overlay. So the polygons that you have extracted, if you click on this button, they will be removed for the time being, and you can see what is underneath them. So just click on this once and click on this once again. So it just keeps toggling your overlay, and you can see what polygons have been extracted. Click on this one more time and you are back again in your query box. So the great thing about Overpass Turbo is that using nothing more than a browser, you can extract vector layers from the OSM database. And once you get a hang of it, you can directly alter these queries and extract vector layers of your choice by directly writing or tweaking the particular code. And this is the Overpass query language. It's quite different from the SQL or SQL syntax. So you'll have to work a little bit to get a hang of it, but you can actually directly alter the code and even do some things that are not possible from inside the QGIS Quick OSM dialog box. So let me just show you one more example of how you can directly alter the code and bring out something more, altering the code inside the code box. So for this example, let's head to the town of Chandrapur in the state of Maharashtra, where there is a very big coal-fired super thermal power station. So I'm going to type in Chandrapur, Chandrapur, and of the options that we see, we want to pick up Chandrapur, Maharashtra, India, this one. That is the fifth option here, Chandrapur, Maharashtra, India. Just click on it and you will be transported to that area. Use this button to zoom out and just keep zooming out till you see the boundary of the thermal power station. So this is the boundary of the thermal power station, Chandrapur Super Thermal Power Station. This is a coal-fired power plant, and this is the town of Chandrapur. What we want to do now is to find out all the coal-powered units inside this area and also the schools inside this particular area. So the idea is we want to see which schools are in proximity that are likely to be impacted by the effluent coming out of the plant. So what we can do is we will come to the wizard. Let's just delete this, and we have already seen this. So we are going to use amenity as the key. Amenity is equal to, and within quotations, SCHOOL. And then I'm going to use another key value pair to extract all coal-fired units. And the key value pair is generator colon source. So this we are using equal to, and the value that we will be using is coal. So you can use generator colon source to extract power units having different sources of fuel. In this particular case, we are using coal. So amenity is equal to school inside quotations, or generator colon source is equal to coal. So we can now come and build and run this query as I have shown you before. And sure enough, we have nodes that are showing us schools and coal-fired units. So as we can guess, nodes that are inside this boundary of the Chandrapur Super Thermal Power Station, these nodes, they are likely to be coal-fired power units. So if you zoom in a bit and come and click on top of a node, you should be able to see details or attributes of that particular node. And you can see generator colon source is equal to coal. So this is a coal-fired unit, as are all these others inside this polygonal area. And let us zoom out a little bit, and all these nodes that are outside the boundary of the thermal power plant, they are likely to be schools. So if I can come here and click on any of these, you will see that this is a school. So The query for this is available here, and you can see that the first part of this query, this part, is actually bringing out schools, nodes, ways, and relations, where the amenity is school. So all the schools have been brought out using this particular part of the query. And the bottom part of the query is bringing out all the coal-fired plants here. So if you knew a little bit of Overpass query language, we can come here and style them a little differently. So we can use some CSS type styling syntax here. So we'll just put two curly brackets, type in style and put in a colon, and we have to close these also. So I'm going to do that right here, two curly braces, and then come here and then just start styling. So you can say node and then two square brackets, and we are going to say amenity is equal to school. So we are just about to style schools. Close the square bracket, come down right here, and then using a curly bracket, we can then just start using CSS style keywords. For example, color, colon, red, then semicolon, and then we can use fill dash color, colon, red, then semicolon. We can also use the width of the boundary line, width, colon, 4, and so on and so forth, and then close it with a curly bracket. So we are done here. Let's run the query, and you will see that all the schools are now in red. So we can now repeat the same for our coal-fired plants. Just copy this piece of code and then just simply come here and paste it and just replace the query, and we will just use generator colon source is equal to coal. You don't need quotation marks here, and then just simply go ahead and change the color to blue and also the fill color to blue. So generator colon source is equal to coal. So our schools will be shown in red, and the coal-fired units are now being shown in blue. Now what we can do here is, in Overpass Turbo, you can share this map with other people. Just click on the share button, and then just make sure that you click on this and then copy this and send it across to other people. They will be able to see this exact same map right here as you see it, along with your query. And that's all you need to share this particular view with other people. And of course, you can always export it and create a PNG for presentation, as I have explained before. Now, say for example, we wanted to find out all the schools that are within 3-kilometer radius of coal-fired plant units, maybe just to indicate that they face a lot of risk in terms of breathing polluted air. So what we can do is, we can then tweak this query a little bit, and I'm just demonstrating this to show you possibilities. This is something that you would ideally be doing inside a GIS, but if you wanted to do it here, the Overpass query language permits you to do some of these things that you cannot do using the quick OSM dialog box. So what we are going to do is, we will bundle up the first query, and we will just come here and put a bracket, and we're going to put a bracket here. So this entire query that brings out all the schools, we have put inside two brackets, and then we will just simply save this output using a dash and a greater than sign space into a variable called as schools. So all the schools that we are bringing out, these red ones, they will now be stored inside a variable called as schools. We will repeat the same process here and bundle up all the power plants and save them inside dot plants. We will need to close this sentence with a semicolon. That's the syntax. So now we have two variables. all the schools are now inside dot schools, and all these blue plans are inside a variable called as dot plans. And just before we print out the result, we can then just simply expand and create a blank line. And then we can use a shortcut NWR, which stands for node, ways, and relations. And then we can just move forward and say dot schools, start a bracket around dot plans and colon, and this is in meters. So because we want to find out for 3 kilometers, we will use 3000 and close this particular bracket and put a semicolon to close the statement. So what we are saying is I want to find out all nodes N, ways W, and R, NWR relations, all nodes, ways, and relations just like this, where schools, all the schools that we have brought out, they are around, and all the plants are inside the variable dot plans, around dot plans, colon, within a distance of 3000 meters. Schools around plants within a distance of 3000 meters or 3 kilometers. So we expect to see some of these schools dropping out as a result of this query, and let us run this query and see what happens. So these are all the schools that are within 3 kilometers of coal-fired units, and you can just simply go ahead and export them as GeoJSON and then use it inside your favorite GIS package. So what I'm basically trying to show you here is that if you learn a little bit of Overpass QL or query language, you can then tweak the code that you have created using the wizard and then do things that are otherwise not possible using quick OSM. So this brings us to the end of this 3-part series on downloading free vector layers from OSM. I hope these videos can help you get started to get vectors of your choice for your GIS projects. Many thanks for watching, and I look forward to seeing you in my next video.